Good afternoon, everyone. Am I audible?
Yes, sir.
Yeah, thank you, ma'am, for confirming. So we are starting in 1 minute. Let me see if some other will join. So good afternoon, everyone. Welcome to the last day of the faculty development program. In today's lecture, in the first session, we will discuss about data analytics. We will cover 4 types of data analytics with Python code. Then in the second session, we will move to big data analytics. And then in the last, we have one quiz for you. So this is the outline of today's plan. So one question that come in our mind is, why data analytics? Why? So if we look a simple example, if we'll take a very simple example, any grocery shop nearby. So what they will do, the owner of the shop, he will forecast the sale based on the inventory what he is maintaining. So based on looking the past sale number, he can predict how much stock he should keep, how much item he should keep in the stock. Similarly, he will keep the track of how many customers on daily basis there are visiting. So all this information, all this data, it will help the shopkeeper, it will help the grocery owner to plan his business. Similarly, if we go to the technical side, we can think about how the Netflix is analyzing the data and they are suggesting movie to us. Similarly, if we think about any e-commerce website, we will see we are getting a lot of recommendations from the e-commerce website based on our purchase history. Similarly, sometime what will happen, we are purchasing the item based on the recommendation of the e-commerce website. Maybe because some of our friend or some of person who has the same interest like us, that particular person has purchased the inventory, that particular person has purchased the item from the grocery store. So I am again saying again some word data again when I am talking about this part. So in this lecture, what is our plan? We will use, we will say what is data, what is data analytics. So we will see in the real world scenario, companies are using, they are making decision, they are using data to make the decision. They are actually making their business insightful by analyzing the data which they have with the help of the technology. So in this whole topic, our agenda will be to understand what is data analytics, what are the different types of data analytics, why data analytics, and in the current scenario, when we have large volume of data, when we have very different variety of data, when we are generating data with a lot of pace, we have the velocity of the data is high. So in all those scenario, how we can come up with the technology, which technology we can use. So that is the agenda of our today lecture. So we will start with the basic terminology in the starting. What is data? So first thing we have to understand is what is data. So data is a raw fact and figures. So it is simply a raw fact and figures that can be processed to extract the information. So in this definition, we have two words. One is the data and second one is the information. So let us distinguish firstly what is data, what is information, and what is the relationship between data and information. So as the definition say, data is a raw fact and figures. So it is simply a collection of fact. So raw fact means there is no any meaning we are assigning to the data. But what is the information? Information refers to process data that has a purpose and that has a meaning. So ultimately, what is our goal? We have data in the raw form. Ultimately, we want to process the data to extract some information. And ultimately, once we have data, from the data, we are extracting the information, and from the information, we are extracting the insight. So this is overall agenda of the plan. So data drives decision in business and science and healthcare. So we will use the data to make multiple decision in business. For example, data helps leaders to make informed choice about the product, marketing, and customer services. In healthcare, it will help us to have the patient care. It will help to search the medical record accordingly as per our requirement. Now, what are the different types of data we can have? What can be the different examples in which form we can have the data? So we can have data in the form of numbers. We can have in the form of text. We can have in the form of image, audio, and video. We can have the multiple forms of data. So based on the examples of data, how we can classify the data. So we have different types of data. We can have the structured data. We can have the structured data. We can have the unstructured data. We can have the semi-structured data. Similarly, we can have the quantitative data. We can have the qualitative data. So if we take a simple example of the structured data, so all the data generally that is adhered to some schema, like in the RDBMS, we have data in the form of relational models. So we have some fixed schema. Such type of data is called structured data. So data is organized like a spreadsheet, like a database. When we have the fixed schema, it becomes easy to search, it becomes easy to analyze. Similarly, when we have the unstructured data, so what is unstructured data? Data does not have a specific format. Like in the structured data, when we talk about the structured data, we can take a simple example of row and column data. So that has some fixed schema. But when we talk about unstructured data, it is not adhering to some specific format, like the email body actually, social media post, image, video. So they are not adhering to some fixed schema. So when they are not adhering to some fixed schema, it can be hard to analyze them, but it holds a valuable information. So in the real world scenario, when we are working with the data analytics, it may be possible that we have to work with the structured data, we have to work with the unstructured data. And in the real world scenario, only 10% of the data is actually structured, and 90% of the data is actually unstructured form. So because a lot of the data is in the unstructured form, so as a data analyst person, we have to understand how to deal with the structured data and how to deal with the unstructured data. So beside that, there is one category that is called semi-structured data, or you can also say semi-unstructured data. So sometimes we can also, it is the part of unstructured, and that is why I mentioned 10% and 90%. But in the 90%, we have 80% data that is not adhering to any fixed format. But there is some data, 10% of the data is that is adhering to some semi-schema, like the JSON file, like the email. So email body is something unstructured. If I will say email, so in the email we have some fixed, partially fixed schema, like we have to, from, BCC, CC. So we have some partial schema. So based on which we can say email is a semi-structured data, but email content, body of the email, that is we don't know what Kuldeep will put into the email, what Mohit will put into the email body. So we don't know that part. So that is something unstructured data. So based on that, we can have, in general, we have the structured data, semi-structured data, and unstructured data. And when we have to process, as a data analytics person, we have to think about how we can process the structured data, how we can process the unstructured data, and how we can deal with the semi-structured data. Similarly, we can classify data into another category, that is the quantitative data and the qualitative data. So we have one quantitative and second one we have the qualitative. So as the name suggests, sometimes we have data in the numerical form. So numerical data that can be measured and compares. Such data is called our quantitative data. For example, sales number. So like if we have some grocery shop and we can easily measure the sales number, it may be 100, 200. So number of customers visiting the store. Again, it is something quantitative value. Similarly, marks in an exam. So such type of values which we can easily measure. Such type of data is called quantitative data. So while quantitative data is rich in detail, it will be of course easy to understand as well. So what is the qualitative data? This is the descriptive data that can provide insights into opinion and experience. So example of qualitative data includes like customer reviews, interview, feedback from the customer. So for instance, a customer review about anything is there. Okay, no issue. So qualitative data is something like which we can't measure. It is a descriptive data. So while it is will be difficult to quantify such type of data, and we can't use statistical measures to analyze this data, but it will play a critical role in understanding the human behavior and improving the product and services of the customer. So now we have the brief idea about what is data. Now we are moving to the next part. What is data analytics? So data analytics is what? It is a science of analyzing raw data to make conclusion about the information. So it is simply what we want to do. We're analyzing the raw data to make some decision. Why? Because ultimately our goal is to optimize the business performance. So it will reveal, data analytics reveals some trends and matrices that will otherwise be lost into the data. So if you take a simple example in the marketing strategy, many companies, they will give the offer by analyzing the data. Like I can take the example, we will take a real world example of a dummy example of e-commerce case study. Like in the e-commerce website, if sales of a particular item is decreasing, so company can plan marketing on accordingly. Like they have to market that accordingly. Similarly, in the flight offers, what the companies will do, like most of the company, what they are doing, they are analyzing the purchase history of the customer. If they are finding that some customer is loyal to them, some customer is recurring, probably they can offer some coupon to them. Or let us say even they found that some customer is not coming again and again. So accordingly, they can offer some coupon so that that particular person will come to their flight, to their website to get the offer. So depending on the nature, companies plan offers. I know a very simple example of data analytics. In the market, if we'll go to the grocery shop, probably it is our normal tendency. We will ask the price of sugar and such type of stuff from the grocery store. Why? Because sugar is one of the commonly bought item by a customer. Similarly, when we are going to some fruit market, we will probably ask the price of potato and tomato to the fruit and vegetable owner, shopkeeper. Why? Because these are the frequently bought item. These are like commonly bought item by the customer. Now, if businessman is smart, what he will do, he will keep the price of potato, tomato, and sugar and tea, these items to be very low so that he can attract the customer. So all these stages, because he know which items are currently sold item, he make planning accordingly as per the requirements, and it will help him or her to make his business fruitful. So now, why data analytics is important, we are covering in detail. So firstly, it will help to make informed decision. What it means, business can make data-driven decision rather than relying only on the intuition. Like one approach is like we will make some guess to make the decision. Second, we have some data, and based on some quantitative measures, based on some qualitative measures, we will take some informed decision. And when we can take the informed decision, when we have some data, and we can optimally able to analyze that data to make the decision. Second is the improved efficiency. How? How data analytics help us to improve the efficiency? By analyzing the operations, organization can identify the bottleneck and they can optimize resource allocation by optimizing the proper resource allocation, like e-commerce website. So e-commerce website has to one part of the e-commerce website is putting item on the platform. Second, ensuring proper delivery of those items to the customer. So if they are able to know what is their sales, what is their data properly, then only they can allocate proper resources. Similarly, in the manufacturing company, they can analyze the production and streamline the process and reduce the cost. Similarly, data analytics will help us to enhance the customer experience. How we can enhance the customer experience? Like by analyzing the sentiment of the customer. Similarly, by analyzing the customer preference, by analyzing the customer behavior. Ultimately, we can say by doing the text analytics of the different behavior of the customer, we are able to make some decision. we can able to know what are the past purchase. Accordingly, we can ask the new offers, we can ask the relevant offer to the customer, and in that way we can enhance the customer experience. Like I know one of the case study based on that in China. There is in the mall when we will go to any popular mall in China, what they are using. So depending on the customer, when you enter into the shopping mall, so they will take your picture. So once you will enter the mall, they will take your picture. Now, based on your picture, they will do some image processing, and they will capture the all past history of the customer. When the particular customer visited the store, what item actually he bought from the store, based on that experience, based on that past history, what actually they will do, they are using augmented reality, virtual reality to suggest the offers to the customer. So there are some display in the shopping malls. From the shopping mall, when you visit to a particular rack into the shopping mall, depending on your image, they will reflect the offer to you. Also, they will send some SMS to you that will suggest depending on your past history, such items are in the stock and you can take such type of offer from us. So it is something like in the real time, they are processing the face of the customer. By processing the face, they are suggesting some offer to you. So even it is not possible in the real time sometime as well. Like I know one example in the Singapore, there is some big mall. What they are doing, they are registering with you and they will send you SMS, occasional SMS for the offers. Why? Because they know my customer behavior. Like because I'm Indian, so they know like when I'm visiting their mall, probably they will suggest me offer based on my past history. So accordingly, they're sending me the SMS when I was there. So they're sending me the SMS like this stuff is coming into the market. This stuff is in the store now. You can buy. So according to such type of offers, they can make by sending SMS, by sending email. So we can enhance the customer experience when we are able to analyze the data properly. Last one, we can say staying competitive. So data analytics will help to identify the market trend and market customer preferences. By identifying the market trend and customer preferences, of course, we can stay competitive into the market. A real world example is Airtel. So Airtel targeted the area where the signal is not available. And still you can see out of a few companies which now popular, Airtel is one of them. So they are able to stay competitive with the market. So they provided the offers accordingly. They choose where to install the towers according to the need of the customer, according to the demand of the market, and accordingly they stayed competitive into the market till now. So these are some of the example where companies are using data analytics. So Airtel is one of the greatest study of the data analytics, where they analyze the data and make the decisions. So when we talk about data analytics, so we can classify our data analytics into minimum 4 parts. Now we have the real-time data analytics as well, near real-time data analytics as well when it comes to big data analytics. But in general, we can classify data analytics into 4 parts: descriptive, diagnostic, predictive, and the prescriptive. So what are the four? Descriptive, diagnostic, predictive, and prescriptive. So as the name suggests, so we will cover each of these in detail. The next 1 hour is on only these 4 types of data analytics. So what is the descriptive meanings? Descriptive means description. This word comes from the description. So it simply means what happened. So we are figuring out what is going on actually. So this type focus on summarizing the historical data to understand what has happened. Simply our focus in what has happened. So for example, when we take about the e-commerce website, we can look at the monthly sale report. It will provide us the insight like how sales performed in the past. By looking at this data, business can identify the trends, they can identify the seasons, where is the spike in the sale. They come to know various trends like who are their loyal customers. They can even identify what is the average order value, what is the return rate of the products. Like if there is a more return rate, probably then they have to think about why it is happening. So that comes in the later part. That comes in the diagnostic analytics. But what is happening? So simply the company, what they are doing, like in the case of an e-commerce website, they're generating their daily report, weekly report, monthly report to identify how many items are sold, which product has the highest sale, how many users are visiting the website, what is the return rate, how many orders are code on delivery, cash on delivery, how many orders are like based on credit card payment, how many orders are based on UPI. So this is something what they are analyzing based on the available data. They are neither focusing on why it is happening, they are not focusing on what will happen in the future. It is just description. So they are simply doing the descriptive analytics. So next type of analytics is diagnostic. So in the diagnostic, it comes from the diagnosis. So it is something like what happened. Like I have today, let us say, just actually I have cough. So there is a description. I have cough. Okay. So diagnostic. Why it happened? Maybe just yesterday it was Holi, so I played the Holi, and that is why I'm feeling like I have cough because of the water, all those issue. I have the cough now. Why did it happen? Because yesterday I played some. I was busy with some festival. In the night there is a rain in Kurukshetra, so like multiple factors are there, and that is why I am feeling cough now. So what happened? Why it happened? Just because of some reason. So like in the e-commerce website, what is the diagnostic analytics? Why did some happen? Why did something happen? So we are exploring in-depth insight of our problem. A simple case. Let us say based on the descriptive data, I come to know churning rate. The customer is churning out. The same customer is not visiting to buy the same product again or different product to my company, my e-commerce website. So why did it happen actually? So maybe multiple reasons are there. Maybe there is a product defect. Maybe there is some negative review. Maybe some competitor is promoting the things. Maybe the seasonal trend. Like if I will say the purchase of AC, what happened? Purchase of AC is more in the winter, more in the summer, and less in the winter. So what happened? Sale is declining when I'm moving from the month August to December. Why it happened? Maybe just because of the season. So such type of analytics, diagnostic analytics, why it is happening? Why the sale is decreasing for a particular product? Why my reviews are increasing negative day by day? Why I'm getting more return? Maybe I am not able to my the like why I'm getting more return product. Maybe we are not able to my this one what you will say this shipping service is not proper. So all those factors will affect the your business, and that comes under the diagnostic analysis. So next is the predictive. Next is the, so it is simply what happened. Second is why did it happen, and third is the what could happen, what will happen. So predictive is what could happen. So in this case, we will forecast and predict the future trend. So based on our data which we have available with us, we will predict the future trend. We'll forecast the future things. For example, any e-commerce website, they can use predictive analytics to forecast the future sale, to forecast the customer behavior. They can use it to forecast the product demand. A simple example I can take again this way, like based on the past shopping pattern, they come to know like in this year, what is the sale of the AC? So what could be the sale of AC in the next year? Like in this winter, in the past winter, the sale of coat was so much. Raincoat or some other coat is so much, or maybe some other type of things. So what will be the future trend in the next year? So predicting such type of things, that comes under the predictive analytics. So what will happen? Like based on the current situation, what will happen in the future? That is the predictive analytics. Then what that is, then next is the prescriptive analytics. What should you do now? What should you do now? Prescription. Like how we can understand this example? Descriptive. I have cough. Why? Just because I played holy yesterday. Predictive. What can happen in the future? Maybe I have fever. So prescriptive. What should I do now? Of course, I have to take medicine. Similarly, when we did in the e-commerce website or any example, prescriptive, what should we do? Like what should we do now? Like let us say my future sale is decreasing. I am finding the trend, my sale is decreasing. So accordingly, what should be my recommendation? Probably I have to give more offer. So that is something recommendation we will do. By analyzing the data, by making predictive analysis, by doing the diagnostic analysis, we come to know why it is happening, what will happen in the future, what actually has been happened. Now we will provide the recommendation. We are providing the recommendation. Key recommendation means what should we do now? Like probably like in the case of e-commerce website, we should have some optimum price strategies. We should have some inventory proper management. We have to focus on personalized marketing. So all those scenario that comes under the prescriptive analysis. Like if I'm churning out customer, like I'm visiting the website regularly, but suddenly I stop buying product from the website. So one of the reason may be that I'm not happy with the service provided by the e-commerce website. So in that case, probably they have to send me the message again and again. They have to send me some more offer so that the company can lure me with more offers, and I will start again buying item from their website. So all those things plays a critical role when we talk about the different types of data analytics. So in brief, what I want to say here, data analytics, we have the four type. Descriptive means what happened. Like in the case of e-commerce website, we are analyzing the past sale, number of visitors, popular product. Diagnostic means why did it happen? So we are identifying the reason behind sale drop or high return rate. So predictive means what will happen, what could happen. So we are forecasting the future. And prescriptive means what should we do? What should we do now? So probably recommending the price strategy, inventory management. So all those things, marketing action that comes under this particular type of category. So these are a few further real world application of the data analytics, like in the retail, in the healthcare, we can use in the finance, we can use data analytics in the sports, we can use data analytics. So in the retail, we are already covered in detail with the example of the e-commerce website, how in the retail data analytics plays a critical role. Similarly, in the healthcare, like we can use predictive analytics by anticipating the customer needs. So we will predict which patient are at the risk of some particular condition, and accordingly we can suggest some treatment plan. Similarly, in the finance, we can detect the fraud by analyzing the data. Similarly, in the sports, like we can analyze the past data to plan the team, to plan the which bowler should bowl now, which batsman should bowl, come to batting order. So all those things like plays a critical role. Like all the past data plays a critical role when we talk about the real example of data analytics. Now we are taking a sample case study to understand this part. So So we are taking a simple example of e-commerce website, e-commerce data, and our ultimate goal is to do all the four different types of data analytics. First one is the descriptive, then diagnostic, then predictive, and the last one is prescriptive. So I'm creating some dummy data instead of using some real world data. Some data are available on the Kaggle, but those are 60,000 lines of that has 60,000 instances. But being in academia, for my students, I have taken some dummy example which we can use to understand the four types of data analytics. So I'm using the Google Colab. So firstly, I'm mounting my Google Colab drive so that I can use my Colab like drive to host the code and to host all the data set. Okay. So initially there is no any data initially actually. So I'm deleting this file. So I am mounting my drive. So what simply we are adding from google.colab import drive. And now we are mounting our drive to this notebook, Python notebook. So now further I'm importing some libraries, pandas and numpy, because I have to work with those library to create multiple data frames and to work some numerical operation. Okay, what I want to do, I want to create a data set. I want to create a random data set that has 50 records. If I will do here, let us say 600, then probably it will create the 600 records. If I'm doing here 500, it will create the 500 records for me. I have set the random state to be 42. We can choose any value here, 1, 2, 3, whatever value we want. It is why I'm choosing 42. It is something magical number. Those who have past experience in ML, it is like last day. So I'm not going in detail of those things. But just briefly, I will let you know what the seed will do. Like sometime we want to replicate the result. Like I'm running this Python notebook today. Maybe I want to run this Python notebook tomorrow as well. So I want to ensure that my results are like I can replicate my result. Like let us say I'm training my model today in the machine learning. Maybe in the future, when I'm training and testing the model, I expect that I will get the same result what I am getting today. Or simply what model I have trained today, what data I have created today. Maybe in the future, when I am running this, I want to get the same data set. So to ensure that we have the same split, we have the same data, we have the same seed in the future, we will use that random dot seed and we are setting it to be any value. We can, when I'm using 1, it will do random, it will set a random seed accordingly. When I'm doing 2, it will set a random seed accordingly. So I can choose any value. 42 is just a magical number in this area. You can choose any value, that does not affect the result. So now we are setting one variable, number of records to be 500, and we have set the random set to be 42. Now based on this random seed, then I am generating my data that would have the 500 records. उस डाटा सेट में कितने रिकॉर्ड्स होंगे? That should have the 500 records. And what is the nature of record? Because I want to do some e-commerce data, so I created some I created the elements. I generated the sample data that has transaction ID, customer ID, age of the customer, gender, product ID, category, quantity, price, purchase date, and the feedback has the attribute. So if you will look here, you see I don't have any data set here, and I want to create some dummy data set. So with the Python, how can we generate some random data? So what we are doing, we are creating a transaction ID which will be the size 5, length will be 5, and we are giving value from 1 to, let me create first, then I will let you know. So in that way I am creating this one. So it is some slowdown. It is shaving, so it will take some time. Yeah, so it will be created. So if you will look at the 2 file here, you come to know here. So this is the data now generated. So first field is transaction ID. So we are creating the transaction ID from 1 to, you will see it is up to 500 accordingly as per the requirement. Okay. So then we are creating a customer ID randomly, because it may be possible that some customer can come again and again to buy to the e-commerce website. So that is why instead of taking the same value 500, we are taking a random ID from 1 to 100 to make my dummy data. So I'm assuming I have 100 customer and each has some unique ID. So we are creating the customer ID in the range from 1 to 100. Similarly, we are creating the age from 18 to 65 randomly for the customer. Then gender, male, female. Then product ID, like he is buying, let us say, some product. Then the category of the product, it can be electronic, clothing, home, book, beauty. Then quantity, so how many items he is buying, let us say maximum we are keeping 5, we can keep any value as per requirement. Then the price of the item, then purchase date on which the purchase item by the customer, and the last one is the feedback. So what is the feedback given by the customer? So based on, we are generating some random data. It is just for academic purpose. Of course, it is not the real world data, so there may be some issue. But for our purpose, for our understanding, all the 4 types of data analytics, this data is sufficient. So from this data, we come to know we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 attributes, and we have 500 instances in this case. So simply we are storing data into the CSV file. So how we can store data frame to_CSV. So this is the way by which we can create the CSV file. So this is our data set for now. Now we have to do some more operation on this data. First type of operation that we want to do is the descriptive analytics. Descriptive means we are simply analyzing this data, nothing else. We are not focusing on why it is happening, what could happen in the future. Our main goal is only on the description, what will happen. So it is the first type of analytics that we will cover. So we will focus on simply summarizing historical data to understand based on this data what has happened. So descriptive analytics mainly focus on a few things. What it will focus on? It will focus on data aggregation. It will focus descriptive analytics. It has mainly 3 things. It will focus on where is the marker? It will focus on data aggregation, So it involves simply we are collecting and summarizing the data from the various sources to provide a comprehensive view of the performance. Then simply we can generate some structured summaries, key matrices, trends that comes under the reporting part, and then some we can do the visualization part. We will make some visualization of the data. So in the case of e-commerce website, like that example we are taking so far. So a simple example is like we can focus on sales trend. We can focus on customer demographic. We can focus on product performance matrices. So we are covering a few of those one by one. So firstly, we are reading the data set which we have created so far. So data set will pd.read csv, simple command. Then this is our data. We are reading the first five. Head will give the first five records of this data. We are getting this one as per our requirement here. So this is it denotes like it is not able to display all the record, but single record in the one line. So it is split to the next line. So we have now, if we look at the summary of this record, so it will give us all the summary of the record. Now, what type of statistical now we want to do? That is our main part. So firstly, let us say we want to see the overall sales analysis. We want to analyze the overall sale. So how we can do the overall sale analysis? So simply, if we look at our total data, so this is the total sale. So one of the analysis is what is my total sale over the given period of time. So simply case I have to do the sum of total sale. So total sale is data total sale dot sum. So in that way, I can get my total sale to be 3,89,133.55. And what is the average sale per customer? I can do the simply mean to calculate the average sale per transaction. Now I will share the same thing one part, how this random sale will affect the result. See, I am setting the random sale to be 42. When I am running it again, it will generate the same data set. It will generate the same data, and you will see there is no any change into the record. There is no any change in the record. All values are same. There is no any change. Now let us say I am setting the random seed to be, let us say 2. What will happen now? The probability is that I will get the different result. Again, it is a probability. So I am not saying surely. It will be the probability that I will get the different result, because I tried in the future, I will go to the different result. So let us see. So it is 3 lakh. It is now different. Just because of the seed, I am getting the different result. Okay. So in that way, you will see how the seed will affect. I can replicate my result with the 42 when I am setting the 42 seed. So that is something the purpose of using the seed in our analysis. Now, this is my one of the stat which I will get with the help of the descriptive statistics. Like I am able to know what is my total sale and what is my average sale per transaction. So as a business person, I can use it to make some analysis. Okay, my sale is sufficient and average sale per transaction is approximately 793. So this is what I am getting. So in the future, to know why I'm getting this, I can go with the diagnostic analytics, and now to forecast what can be the future sale, I can go with the prescriptive and predictive analytics as per our requirement. So let us say one case is like I am surprised. My average sale per transaction is very, very less. It is 793. So what maybe because I'm not giving offer, that is maybe the reason, or I'm keeping free delivery to be on the 200, and that is why people are making 800 rupees order. So what can I do? Maybe I will increase the delivery charges, or I make free delivery to be less than 500, or maybe more than 500 accordingly. So such type of insight I can do for the future transaction. Similarly, I want to know how many customers are male, how many customers are sale, which are frequent flyer for me, which are not. So I can use such type of analysis here. So now based on that, I am able to come to know female customers are buying less purchase and males are doing more purchase. So such type of analysis. So my main target should be like I should have to increase the female sale. Customers, I should target the female customer so that they will buy more item from my e-commerce website. So such type of analysis will help us to do such type of analysis. Similarly, we can make some gender graph like that, female and male. So males are more value, female has the less value as per the data set. So what simply we are doing here, we are creating a figure, we are creating a plot sales by gender. So we are creating a bar chart, actually it is a bar chart, and accordingly title, X label, Y label, tick rotation. So what is the purpose of rotation? Simply if I will do set here, let us say 45, what it will do, now it is plane, so it is 0° angle, it will simply make it tilted as per our requirement. So depending on our requirement, we can generate multiple say. Now let us say I want to do one more descriptive analytics. I want to know what is the average order value. So I can do by writing that average order value is simply in that way I can get the average value. I know what is the total sale divided by the quantity. So I will get the order value. Then I'm calculating the mean of all the records to get the average order value. So in that way, I will get the average order value is 258.65. Similarly, I can come to know like because we are selling the different types of product. Some products belongs to home category, some products belongs to beauty category, some products belongs to book category, some products belongs to electronic categories, some products are belonging to customer categories. So what simply we want to do, we want to simply think about, just 1 minute. We want to simply think about, we want to simply know which category products are sold more, which category products are sold less. So we can simply know like beauty products are sold 88K value, electronic products are sold by 80K value, clothing products are sold with 79K value, books with this value, home with this value. So accordingly I can plan, like I should focus mainly on the, like because home product sale is less, so I should provide some offer by which I can increase the home sale product. Or I should plan, because my main product is beauty product, so I should now focus more on the beauty product as well. So I can plan accordingly. I should target on the beauty or I should target on the home depending on the requirement. So we can visualize it in that form as per our requirement. Now similarly, customer feedback plays a critical role. So we can analyze the customer feedback analysis, like how many have given the average rating, how many have given the bad, how many have given the good. So such type of analysis we can do with the that comes under the descriptive analytics. Okay, so we can also plot the value average, bad and good as per our requirement. Similarly, I want to know like by age, what is the demographic overview by the age. So in this case, when we have the age distribution by age, so we come to know like there is 8 pupils with the age 18, 14 pupils with the age 19, 7 people with let me run. So accordingly we will get some value here, different age pupils as per the requirement, and we can create the count plot to know which is the target people. So I come to know from here that most of the pupils which 18 year people are like that, 19 age peoples are so much, 20 year age peoples are so much. So such type of information will help us to know which is my target audience, which is my target audience. Similarly, I can come to know which products are performing better, which products are performing poor. So some product has more sale, some product has less sale. So such type of analysis all comes under the descriptive analytics. So we are simply doing the descriptive analytics in that case. So we are come to know these are my top 10 selling products by the sale. So I have now two options. I should every company has some key items. Probably they will sell these, they will market these more to make the sale of these items to be more. Or we can simply have the last 10 product which are performing very poor. So we can also target we should sell we should do marketing for those items when selling the product. So what we can do with this product 42, it is the most selling product. I can do, I will attach some less sold product with this. When you go to Dabur company, probably they will sell this toothpaste with the Dabur Chyawanprash. Chyawanprash is very it is oversell product by the Dabur. Chyawanprash sale is very large by the Dabur. So what they are doing, they are giving a free toothpaste with the Dabur Chyawanprash. Similarly, with the glucose, they are giving toothpaste with the with the glucose, Glucon-D. Why? Because such products like Glucon-D by the Dabur, glucose by the Dabur, or Chyawanprash by the Dabur, they are top 10 products. They are among the top sold product with them. So they are attaching some product to market that product with as a freebie. So in that way, we come to know this idea how just by analyzing the product sale, they come to know this is the frequently sold product, this is the less frequently sold product. So such type of analysis is only possible when we are firstly analyzing the data based on the description. We are doing the descriptive analytics. Then only we can do, we can forecast, we can make such combination in the future. So next, we can make the sales trends over the time to know what is the monthly sale. So in this simply case, based on the purchase date, we are making the monthly trend. So in our data set, we have the purchase date given to them, and then accordingly from the purchase date, we are finding the month, and accordingly we are making the plot. So we come to know the sale is over the time, sale is not increasing, but it is actually decreasing. So one of the reason for decreasing of the sale may be something, but we don't know what, maybe something that we will do at the time of diagnostic analytics. Similarly, we can do some time-based analysis to know the daily sale. So we can have some daily sale analysis based on our requirement. So this is the daily sale. So all this information, finding daily sale trends, finding weekly sale trends, monthly sale trends, finding the overall history, which products are more sold. So based on data, we are doing some insight that all comes under the descriptive analytics. So this is first type of analytics that we are covering. Again, we can make the correlation heat map based on that. So because data is dummy, so we are not able to get some good correlation map. In this case, there is any correlation. But let us understand what the correlation map indicate. So correlation map, by default, I'm using the Pearson coefficient because I'm not passing any value here. We can pass, we can use any correlation coefficient as per our requirement by passing as the parameter. So in the correlation heat map, we have our variables at the left and y-axis, or it is simply a matrix. Now, what this value denote? Higher value denote that two variables are highly correlated. Negative value denotes so two variables are not correlated, like they are negatively correlated. A value of 0 denotes that two variables are not correlated. So -1 means negatively correlated. 1 means they are highly correlated in the positive way. 0 means they are not correlated. So what it means by the three things, what I am saying here, highly correlated, no correlated, what it means. So let us say I have one variable x, one variable y. So let us say if the value of x is increasing as the value of y is increasing as the value of x is increasing. So as the value of x is increasing, value of y is increasing. So such type of correlation is called positive correlation. So what one means, they are highly correlated. When the case is reverse, so let us say we have such variables here. This is the x, this is the y. In this case, As the value of X is increasing, value of Y is decreasing. Such type of correlation is called negative correlation. But sometimes we have data which are not correlated with each other. So like I'm making one data here. So there is no any trend. Like it is not like when the X is increasing, Y is increasing. So there is no any correlation between X and Y. So such type of relation where Y does not depend on X actually. Value of Y is not neither increasing with X or value of Y is neither decreasing with X. Such type of correlation has a value equal to 0. So heat map denotes all those things. Heat map, what it is will doing? Heat map is denoting those things. So as the value of age is increasing, it does not affect the total sale. So total sale is independent of the age. Similarly, as the quantity is increasing, then the sale is of course, total sale is of course increasing. So such type of relationship we come to know with the help of the heat map. So heat map will help us to know the relationship between the different variables, different attributes that we are considering into the data. So this is the first type of analytics that we have covered, that is the descriptive analytics. Next is the diagnostic analytics. So what is the diagnostic analytics that we will cover in the next part? Give me 1 minute. We will do exam after the lecture. There is some message कि test typing will be probably 7. Next, we have the diagnostic analytics. So what is the diagnostic analytics? As the name suggests, diagnostic means why something has been happened. So why something has been happened. So in this analytics, we'll focus on we are getting these sales trends, we are getting this information. We'll focus on why did it happen. So we are considering some of the cases in this case. So in the diagnostic analytics, mainly we'll focus on approaches like the data segmentation, we'll focus on correlation analysis, we'll focus on sales like feedback analysis. All those comes under the diagnostic analytics. So first thing, we can consider like the data segmentation. So as I come to know my sale is decreasing or my sale is not improving over the time. So let me see some of the data aggregation, like actually what is happening over the time. So I'm making my sales by age group. So what I did, I am dividing my age group into different bands: 18, 25, 35, 45, 55, 65. I'm increasing the font size here. So but ultimately what we are making a band that has the people within the age 18 to 24. Second bin has the people who has the age 25 to 34. Third bin has the people who has the age from 35 to 44. Then fourth has the age group 45 to 54, then 55 to 64, and above 65. So accordingly, I'm making my bins. Okay. So then I'm calculating the sales by age group, because I have to calculate the sale by age group. That we are doing here. We are calculating the sale by age group. Now this is information what I am getting. So what I found that the young peoples are not my like they are not buying the item so much. So my target audience is this age group. Similarly, when we are doing the visualization, we are getting this plot. Font is now very large. So this is my total sales by the age group. So what I found, whether there is any relationship between the age and total sale that I want to see, I found that it is very, very less. There is no any correlation. And similarly, we can use some scattered plot to visualize age and total sale. So this is something we will do in the diagnostic analysis. Then it comes to root cause analysis, in investigating the like impact of feedback. So we come to know like some feedbacks are like average feedback, total sale is like this, bad feedback sale is like this, good feedback sale is like that. So there is no actually we come to know because lot of people have the bad feedback and some of people have given the average feedback and one third of the people has given the good feedback. So that is one of the reason maybe that the sale is not increasing over the time, because good feedback is given by only one third of the person and many people has given the bad feedback. So all these comes why it comes such type of analytics is called descriptive analytics. So now a question may come in your mind, sir, it looks also the part of the descriptive analytics. Why you are saying it is as a part of the diagnostic analytics? See, in this example, when we do the diagnostic analytics, actually we are also first do the descriptive analytics. From the descriptive analytics, we are finding diagnostic part. Why part? So a simple example, in the first case, what we did, we grouped the item, like we group the sale by age group. So while segmenting data by age group looks like the descriptive technique, but our goal is here to how those groups relate to sale. Our focus in how age group relate to the sale. So my purpose here is not to only do the descriptive analytics, like finding only sale by the age group, but I want to know actually why, how these sale groups are related to the, how age groups are related to the sale. So that comes under the diagnostic part. Similarly, later we are finding the correlation between, like when we go correlation between the age and total sale. Of course, finding the correlation between age and total sale is a descriptive part, but here we want to know whether like why age whether whether the sale is improving with the age or not. So that comes under something diagnostic. So it is used to explain the relationship. So that comes under why it is happening, why the sale is not increasing with the age, or who are the people who is buying the item, what is their age group. So how it is affecting. So that is why it comes under the diagnostic. Similarly, customer feedback is descriptive item, but it helps us to understand the impact of customer sentiment on the sale. So we want to know what is the impact of customer sentiment on the sale. That comes under the diagnostic part. So descriptive and diagnostic are it looks sometimes similar, but in one part our focus in what happened, and second looking why actually it is happened. So based on that we have the descriptive and the diagnostic analytics. Then we are moving to the third part of analytics for the same data, that is the predictive analytics. Let us say in the predictive analytics, because we have already done so much on the machine learning, so I'm considering two cases here. We want to predict the price based on the data which we have given with us. We want to predict the price in the future. So we can go with the, so what we have to do, we have to take some of the features. What are the relevant features in this case? See, transaction ID, customer ID does not affect. Similarly, some of the features like product, some of the features we are considering for a rational model like age, gender, category, and quantity to predict the price of the item. So accordingly, we can consider the customer ID as well. It is our choice. So accordingly, some of the features from the data set we are considering as the dependent variable, and we are considering price as the dependent variable. Dependent variable means whose value we want to predict. So when I'm running this part, so this is my regression features which I will use for predicting the price of the unknown value, and then this is the target features. This is the age, gender, category, quantity we are extracting from here from the data set, and this is the target value which we are getting from here. Now in some of the features, like when we will see here, these are categorical features: book, home, similarly clothing, gender, male, female. So we have to convert those into a form that the machine learning model can understand. So then we have to use some encoding here. What we'll do, we'll use the one encoding here. Encoding the part. Yeah, get dummies. So it is a feature encoding here. What we are doing here. So we are converting those features into in a form, in a like binary features, so that machine learning model can understand those features. Then we are simply now using random forest regression to split our data, like train our model. So what simply we are doing here, we have X train regression, X test regression, Y train regression, Y test regression, and then we are splitting our data into two parts, training part and testing part. So now test size has the 0.2. So out of 100 instances, out of 500 instances, 400 instances we are using for the training purpose, and 100 instances we are using for the testing purpose. And we are setting random state to be 42. Again, we can use any random state, just we want to replicate our result in the future. Then we are applying regression model, then we are predicting the and evaluating the model. Similarly, another prediction can be predicting the feedback. So it is the regression problem, it can be the classification problem. So how we will do in the classification problem? So we want to predict the feedback. We are considering some feature from the data set for as the dependent variable, and our independent variable as the independent variable, sorry, and our dependent variable is feedback. So accordingly, we have extracted the feature, then we do the one hot embedding, and then we are actually train our model. So this is something we are getting here. So we are getting some results here. Now briefly let me explain what is precision, what is recall, depending on this scenario. So in this case, when we say, because we have three types of feedback, we have the average feedback, we have the bad feedback, and we have the good feedback. So we are getting some feedback here. Accordingly, we are getting some value, precision. So precision is actually, what is the precision? It measures of all the instances predicted in a certain class. Like for a given certain class, how many are actually that class? How many were actually that class? Like in a simple case, when we are getting precision to be 0.314 average, it means that only 31% of the instances predicted as average were actually average. So that is precision. So out of 100 instances which are of actually average type, we are able to predict only 31% of the instances as the average. Similarly, what is the recall? Of all the actual instances of a certain type, how many did we actually correctly predicted? So that is the recall. And like out of like in our data set, we have 100 instances which are actually average, but our model is able to only predict 33 of those instances as the average. So that is actually recall. Similarly, F1 score is the harmonic mean of precision and recall. Sport is how many actually instances are of average type. Like when we will say our test size has 100 instances, out of those 33 instances are of average type, 32 instances are of bad type, and 35 instances are of the good type, and total will come to be the 100. So this is something like predictive. I am not going in detail of the predictive because all the topics covered so far are based on the predictive analytics in the most of the topics that we covered so far in the 9 days are based on the prescriptive predictive analytics. So next type of analytics is the prescriptive analytics. Prescription. So in the prescriptive analytics, our main focus is we want to recommend some actions. We want to recommend some decision based on the predictive insight. So in the context of data set that we have covered, so we can say by analyzing the sale pattern, we are able to identify which products are frequently sold, which products are not frequently sold. So like a simple case, when we are analyzing our sale pattern, we come to know like home sale is maximum and clothing sale is minimum. So this is something we are analyzing based on the same pattern. Now, what we will do in the case of prescriptive, we will do some recommendation. We will do same recommendation. So based on prescription, what is our, based on descriptive analytics, what is our recommendation? We are recommending here. So I will come to this part that firstly what is understand what we are analyzing. We are analyzing the sale pattern. So we have total sale quantity into price, then we have sorted it and we come to know home has the maximum sale, then beauty, then book, then electronics item, then the clothing item. So this is something descriptive part. Now what is the recommendation? What is the prescription? Recommendation based on the sale pattern. So what are the top category? So we come to know like top category is home. Based on the sale, top category is home. So as a to ensure our proper business. So because this category is focusing like it has the maximum sale for us. So we can focus our marketing efforts on the home category as it generates the most sale. Similarly, we can think about those product. We can look at those category which has the less sale, and accordingly we can plan our marketing strategies. So we are considering the situation here ki which product has the more sale, we should market that more, so that whose sale does not decrease over the time. Like many companies will do that part. They have a few items like Parle-G has one biscuit that is very popular, Parle-G basic biscuit. So probably they should plan more marketing strategy to capture the more market for that biscuit instead of like marketing less selling product by those. So all those recommendations like which product they should sell, which product they should market, which customer they should target, all those recommendations comes under the prescriptive analytics. Okay, so I can take another example here of customer segmentation. Like I want to now segment the customer into different group. Like I have so many customers, and I cannot target every customer. It is not practically possible to target every customer. And what ultimately I will do, initially I will cluster my customer. I will segment my customer based on their sale. Like some customers are buying only less item. Their total sale value is very, very less. Some customers are visiting the website frequently and they have the medium sale value. Some have the high sale value. Some have the very high, like they are frequently visiting. So their total sale value is high, very high. So what we are doing, we are segmenting my customer into different clusters, different group, depending on their total sale. So let us say we are dividing our customer into 4 clusters, 4 segment: low, medium, high, and very high. So simply what we are doing, we are making 4 bean. One bean has all the customers whose total sale value is below 900, 999. Second bin has all those customer who has sales value between 1000 and 2999. My third bin will be all the customer who has total sale between 3000 to 5999. My fourth bin will be from 6000 to any upper value. So accordingly, any value above this value, any value above 6000. So that bin. So it can be low, medium, high, and very high. So we are dividing that into four bins. So based on that, we segregated our customer. Some customers comes under the high total sale bin. Some customers are coming in the medium sale bin. Some customers are coming in the high. Some are coming in the low. So that is descriptive part. Now, how I can use it for the prescription? How I can use it for the recommendation? So I come to know some customers are like regular customers. They have the total sale value more than very high. So what we can do in that case, we recommend. So it is better which we can suggest some recommendation based on the based on the customer segment. Like engage with high value customers. These are my high value customers, and we should be engaged with these high value customer. जो customer बार बार आ रहा है, which is buying more, we should not let that customer to churn out. So we have to engage such type of customers with our business. So that is the recommendation which we will recommend at the time of the prescriptive analytics. Similarly, like we can suggest some discount which have the very low, which customers are not coming regularly, which belong to the low segment. Then accordingly, we should because we have to ensure our total sale to be more for those customers. So probably we can offer some more discount. We can offer some special bonus if they come to buy some item to us. Like in the airline cases, you will see probably if you are the frequent flyer, they will give you some token. They will give you some coupon which you can use. But even if you are not a frequent flyer, sometimes they will send you some offer. Okay, buy with Indigo, travel with Vistara, you will get free food, you will get some loyalty bonus. So depending on the target audience, different recommendation has been done by the e-commerce website. So all those comes under the prescriptive analytics. Similarly, any type of business, we can have the different types of recommendation, and accordingly we have the prescriptive analytics, we have the descriptive analytics, we have the diagnostic analytics, and we have the other type of analytics. So with this case study, we are able to come to know what are the four different types of data analytics. So any doubt into the four types of data analytics, please let me know. I'm some super fast because we have to cover many topics. Okay, so in that way, we are able to understand the four types of analytics. Now we are moving to the second part of this session, big data. Okay, can anyone let me know briefly what do you think by the big data? Am I audible? Okay, I'm sharing the collab link. Sorry. So you can generate the data directly with that as well. Okay, so now we are moving to the next part of this. Can anyone let me know what do you think by big data? For this part, we will go slowly. Okay, so in the real world scenario, whatever, okay, so far we have taken one scenario in which our data is in the form of CSV file. When we did the data net, when we analyzed, when we did predictive analytics, when we did descriptive analytics, our data was in the form of a CSV file, and that has some fixed schema. And I am able to process that data just with the help of my simple machine. I am on the desktop now, and just with the help of the desktop, I am able to process that data. But in the real world scenario, we have hexabytes of data. We have large volume of data. We have the large different types of data, like variety of data. So it becomes difficult to process such large volume of data, large variety of data with the traditional data analytics approaches. Like in the previous class, in the previous 2 or 3 days ago, you have covered k-mean clustering. You have worked on the hierarchical clustering, k-mean clustering, hierarchical clustering. In the previous, on the same day, you focus on the association rule mining, a priori algorithm. So all those algorithms, what they are assuming that our data is actually available into the RAM. But in the real world scenario, when we have the large volume of data, it becomes difficult to store such large volume of data into into the RAM at a given time. So such type of volume, like how we can process such large amount of data, and even it is not the case we have all the data in the similar form. In the real world scenario, like when we talk about the sentiment analysis of or sentiment analysis on the YouTube, our sentiment like YouTube likes, dislike is one part, text comments by the user is one part, the people who watched the video, that is one part. So multiple factors plays a critical role. Similarly, in the e-commerce website, multiple factors will plays a critical role to know the nature of the customer. So data is in the variety form. Data is not all the data in the e-commerce website is not in the form of like a CSV file or in the form of, let us say, audio, or maybe in the form of video. Like the reviews, some reviews are in the textual form, some reviews are in the form of images, some time reviews are in the form of video also. So we have to even handle the variety of data. So to handle variety of data, to handle volume of data, we have to make transition from data to big data. We have to make a transition from data analytics to the big data analytics. So that we will do in this part of the lecture. So what is big data? So how much big? So in a layman term, if someone will ask me big data, simply what we can say, data is so large that a traditional data processing application cannot handle it adequately. So anything that is beyond the human or technical infrastructure need, that we cannot store easily, that we cannot process easily, that we cannot analyze easily, that is simply we can say in the layman term. I'm not saying it is the official definition, that we can simply say about the that is big data. Now a question may come in your mind, sir. Sir, like in the last like 10 years ago, we have like only 1 GB of RAM. Now we have 32 GB of RAM in our desktop, maybe 64 GB of RAM in some smartphone. So we can process now more as compared to that what we do in the 10 years ago. So it is possible that today big, maybe tomorrow normal. जो आज big है हमारे लिए, that may be normal tomorrow. So that is why it is not only about volume only. So in the real world scenario, as per the Galton, the definition of big data is what? Big data is high volume, high velocity, and high variety of information. So what is the big data? Big data is high volume, high velocity, and high variety of information assets that demand. See, because it is now high volume, I will cover this terminology one by one. What is the volume? What is velocity? What is variety? We will cover. We have more as well. Well, like veracity, validity. We will cover all those terms. But the three terms as given by the Gartner dictionary is like big data is high volume, high velocity, and high variety information assets that demand cost-effective, innovative forms of information processing. For what? This is the nature of the data. What it demands? It demands that we should have some cost-effective, innovative way to process this information. Why? To make some decision. So based on this definition, we come to know a few points. Okay, we have to think about some way by which we can store this high voluminous data, high variety of data, high volume velocity of data. Some way to store. Then we have to think about how we can process this way. Why we want to process? To make some decision, to make some insight from this. So simply what we can say, initially we have the data, we have to extract the information from that data. From the information, we will identify some insights and we will use that insight to make a decision. And why we want to make those decisions? To enhance our business value. So simply what I want to say, we have data. So from the data, we have to identify the information. How can I do that part? That is a difficult, critical part. I have to think about how can I store, how can I store, how can I process my data. So once that is converted to the information, then I have to think about some insight. What insight I can get from this information? Finding on the insight, then I have to make some decision. And why I'm making the decision? Because I want to enhance, I want to increase the business value. So that is big data. So now it has a few terminologies like volume, velocity, and variety. So let me cover one by one about this terminology. So what is the volume? So what is volume? Simply let me take. So first terminology is volume. So volume simply means the size of the data. When we have small size of data, like initially in 1970s, generally we work in the batch processing. Our data is in the form of relational databases, in the form of RDBMS, that is following the relational schema. Our data is in the form of only MBs. We have only small data. But over the time, due to advancements in the technology, advancement in the internet, now we have terabytes of data, we have petabytes of data, hexabytes of data. We have so much large volume of data. So we have to think about how we can process it, how we can store it. Next is the velocity. Velocity means the pace, the speed with which we are generating the data. So over the time, when we have the batch processing, generally our data is in the offline form. But over the time, we are generating data from the sources in the real time. We can take the example of e-commerce, let us say Facebook. In the Facebook, in the Twitter, we are posting our tweets regularly. In the Facebook, we are posting our posts regularly. So now the velocity of data, that is the part of the velocity. Now we have to process the data in the real time. So that is actually velocity part. Variety is what is the different range of data types, what is the different sources of the data by which we are generating the data. So variety means we can have the structured data, we can have the semi-structured data, we can have the unstructured data, and we have to think about how we can use different way to handle, to manage, to store our structured data, semi-structured data, or different forms of the data. Beside these, volume, velocity, and variety, we have terminology like uh, veracity. So, what is the veracity means? It refers to whether my data is that has some noise or abnormality. So sometimes our data set has some noise, our data set has some abnormality. So big data also handle all those issues. So it refers to biasness, noise, or abnormality into the data. So is all the data that is being stored meaningful? Maybe some data is not meaningful. So we have to remove, we have to understand the meaning. We have to remove the meaningless data from that part. So that comes under the veracity. Second one is volatility. 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 Volatility refers to life of the data. So in the big data environment, data has life. Like if we will take about the Twitter stream, in the case of Twitter data, yesterday, like day after, just 2 days ago, we have the India and this is the we have the final match in the cricket. So in that case, the stream is accordingly. That stream has more relevance on that day. Today, that stream does not have so much relevance. So even in the real world scenario, when we talk about the sentiment analysis, when we talk about any e-commerce data, that has some duration. Like today, there is no any relevance of COVID-related post which we have posted on the Twitter, which we have posted on the Facebook, because COVID is now not a like any something trending topic. So over the time, data becomes obsolete. Some data has long-term decision impact, and some data has short-term decision impact. So that refers to the volatility. So depending on the volatility of the data, some data are high volatile, some data are low volatile. Accordingly, we have to think about whether we have to process data in the real time, or we can process data in the non-real time. If data is highly volatile, data nature is changing, like Twitter data. We can say, I have taken the example of match case. So that data has no relevance today. So we have to process that data in the real time. And if we have to process data in the real time, then we have to actually ensure our proper storage mechanism. We have to think about our proper processing mechanism. But if data is not volatile, like let us say time series data of vegetation index of some region, let us say Haryana or Punjab. So that data I can store in some location. I can slowly process that to make the insight. So I don't need to go for real time processing to make such type of data. So volatility of data affects a lot whether we should go with the big data related technologies or we should not go with the big data related technologies. Similarly, validity. Next way is validity. It refers to accuracy or correctness in the data. So any data that we are picking for the analysis, that should be also valid. Last one is the variability. Last one is the variability. What it means variability? Data sometimes when we are generating data, it may come with the periodic peaks. Like data flow is sometimes inconsistent. Like in the case of I am taking again the Twitter data, Twitter stream. When there is some match, there is more post at that time. When there is some big event happening in the world, probably you will see more tweets at that time. Similarly, let us say e-commerce website, when they offer some offer like Amazon big day sale, Flipkart independent day sale, you will see more order as compared to the normal days. Like in the IRCTC website, we have more peak in the morning when Tatkal is open. So data is generally coming with the inconsistent flow. And when we have to process this inconsistent type of data, then we have to plan some way by which we can store this data, we can ingest this data accordingly. So all these things, velocity, volume, variety, veracity, volatility, validity, and variability, all these affect how to store the data, how to process the data. And that is ultimately main goal of our remaining part. Okay. So now, why big data? When we have a large volume of data, when we have the more data, we can make accurate decision. We have the more confidence in the decision making, and ultimately, if we have the more confidence in the decision making, it will help us the better offering. We can make reduce our cost. We can make better decision over the time. So we have different technologies which we can use for the big data. First one is the NoSQL. Second one is the Hadoop. Third, in the Hadoop, we have the MapReduce. We have the HDFS. Then we have the data stream mining. Similarly, we have the Spark. So we will cover these technology in detail one by one in the in the remaining part of the slide. So I will cover the NoSQL after a break. So we have break till 5. We will cover this part, NoSQL, Hadoop, and data stream mining in the next part of the presentation. So I'm taking a 15-minute break here. We will resume session at 5. Any doubt you can ask. Am I audible? Good evening. Okay, so far we have discussed different views of big data, which are volume, velocity, variety, veracity, volatility, validity, and variability. So now, what are the different technology challenge that we will face when processing such nature of data? And accordingly, we have to plan some solution to handle those technological challenges. So first of the technological challenge that deals with how we can store large volume of data. So first of the thing that we have to focus on is how to store large volume of data. So first part is volume. So our big data technology should provide us a way by which we can store the huge volume of the data. So in big data analytics, we have the concept of Hadoop distributed file system. Like in our window, we have the NTFS file system. Similarly, we have the XT file system. We have the FAT file system by which we are storing HLA data into our normal disk. Similarly, because now we have a large volume of data, it is not practically possible to store all the data in a processed form. Like we cannot store all the data in one location as well. So we need some database file, we need some data file system that will allow us to store our data into distributed environment form. And that is possible with the help of the Hadoop distributed file system. So to handle the volume, we have to store the data, and how we can store with HDFS. It's providing us one of the way to store large volume of the data so that we can even process it, we can analyze it as or when required. Second part is like when we have large velocity of data, means data is generated from the source with a large pace. So ultimately, first part that come in our mind is like how we can ingest that large velocity of data. So how we can ingest means how we can store that part. Like I can take a very simple example to understand the velocity. If we have one tap and if the water is coming with a slow pace, probably we can use some bucket, we can use some basket to hold the water. But if we don't know about the stream pace, maybe suddenly it will come with a blast, sometime it will come slowly. At that time, probably we cannot rely on only one basket. Probably then we have to think about multiple baskets. We have to think about how to manage the whole stream to handle. So that area comes the velocity part. So to handle the velocity part, we have the direction, that is the data stream mining. How to mine the data stream, how to store the data stream. So that comes under the data stream ingestion and the mining part. Even we will use the Spark to handle the large velocity of data. When we have to do the real-time processing, instead of MapReduce, generally we will use the Spark framework to handle the velocity of data. Second, handling variety of data. Handling variety of data. So since one of the challenge when we deal with the variety is like we have data from different sources and data may be in the different form. Some data is in the structured form, they're adhering to some schema. Some data is not adhering to any schema. So we don't have any like fixed schema like in the early time we had a relational database that are relational in nature. So to store such data, to handle the variety, and we want to process data. So as big data is equipped with the NoSQL databases. So it is the not only SQL. So these databases are optimized for query processing, document processing, etc. So by using the NoSQL, we are handling the variety of data. Now, because we have large volume of data and we have to process it. So to process this large volume of data, large velocity of data, we need to think about some processing framework. So Hadoop is supporting one of the processing framework, MapReduce, to do this part. So in simple form, what we can say, we have NoSQL to query variety of data. We have MapReduce to process the large volume of data. We have HDFS to store large volume of data. So processing via MapReduce, storage by the HDFS file system, and then we have data stream processing. We have Spark that will help us to deal with the velocity of the large volume of data. So we will cover these technology briefly. Of course, it is a large subject. It is a large domain area. Big data analytics itself is a large domain. It is not practically possible to cover all aspects in 1 hour, 1.5 hour. I will try to cover a few of those aspects in detail in the next 1.5 hour of the session. So what is NoSQL? All of we know about the SQL. So when we say about the SQL is structured query language. And if we know about the based on our past experience, these are relational databases. These are relational databases which are adhere to some schema. Like even we have a different normalization form adhering to different schema as per the requirement. So such type of databases which are based on the SQL, relational databases are based relational databases. They have some schema in the tabular form, we simply call the relation form. So we can store our data into these table as the record. But because now our data is in the different form, it is not our data is now not adhering to some schema like in the previous case, like the batch processing case. Our database is adhering to some schema. Now data is not adhering to any schema. So we have to think about some alternate way by which we can store our data, and that leads to the area of the NoSQL databases. So NoSQLs are open source, non-relational, distributed database. So what is the meaning of each part? Open source means it is open, so it is freely available. You don't need to pay anything for using the NoSQL based oriented databases. Non-relational means they are not adhering to any fixed schema. Like in the case of SQL, those are relational. There is some relationship between the different elements. There is some relation, but there is no any relation in the case of the NoSQL databases. Third, these are distributed databases. It means now it is not compulsory that our data will lies only at one of the location, at one of the physical or logical location. It can be logically or physically separated at the different location. Now, when we have these things, ultimately we come to know because our data sets are now non-relational, so it may not adhere to the ACID property. But now it is the distributed database, so it should adhere to the CAP theorem. I'm not going in detail of this. So ultimately, just I want to conclude that part. These are something non-relational databases, and depending on the application or depending on our nature, we can use any of the type of the NoSQL databases. And now when I'm using the word type, so we have 4 types of NoSQL databases. There is one more now, time series data as well, but we are focusing only on the 4 type, which are, first one is the key value pair, key value. Second one is the document. Third one is the columnar. Fourth one is the graph based. So what is the meaning of each? Let us cover one by one. So when the word key value comes, so firstly we are covering the key value pair database. As the name suggests, key value. So when the word key and value comes, it means these are hash table based data. These are hash table based data. What it means? We have some key and corresponding to we are storing some value. How we can visualize it as one example? Let us take the example of e-commerce website. So I'm taking the example of e-commerce website. I'm taking the example of e-commerce website. In the e-commerce website, so I have different types of product. Like in e-commerce website, I can store book detail. Some of the items can be book. It can be refrigerator. It can be even let us say AC. It can be even let us say CD. It can be anything. So in the e-commerce website, because different items have different properties. Like when I say about the book, when I have to store the record of the book, probably I need some field like book name, author name. Give me 1 minute. Yeah, author name, maybe publisher name, price, edition. So such type of information I need when I'm making inventory for the book, when I'm making a record for book into the e-commerce website. But when I'm making the record for AC, let us say AC, probably I have the other field like what is the model, what is the company make, what is the price, what is the capacity, etc. Similarly, if it is let us say instead of AC, instead of book, it is let us say some garment. Then it may be for gender, for which gender it is, unisex, for male, for female, for kid. It can be for like let us say price, similarly size, color. So I have the different field. So when I have the now all these are part of the inventory. Book is the part of inventory, AC is the part of inventory, garment is the part of the inventory, but I cannot use any single table because all these are part of inventory, but they are not adhering to same schema. Book has the different attribute, AC has the different attribute, garment has the different attribute. So I cannot create any relational database. I can create a single table like in the SQL in which I can store book detail also in the same table, AC detail into the same table, garment detail, because attributes are changing. They are different. Book has a different attribute, AC has a different, garment has the different attribute. So I have to think about some another data model. I have to think about some alternative to SQL. And in the NoSQL, we have the idea about the key value pair to handle such type of thing. So how we can store this in the key value pair? Let us say I'm making my key as product ID. So my key is product ID. Let us say 1 is my product ID. So product ID, I am making product ID 1. Even I can note down the type. So depending on product ID and type. So if the type is book, so I can make this is my key, which will distinguish between the two part, a particular value. So my value can be like for this key, value can be let us say name of the book, book name, author's name, then price, then accordingly edition, something like that. Let us say another book ID is 2. This is the book. Let us say it is the computer network book. This is let us say C book. Then accordingly author name can be let us say Kanitkar accordingly. Similarly, I can have some product ID 1. It comes under the let us say electronic item, and maybe I can make subtype or AC as per our requirement. And accordingly I have the then model, make, price, capacity as the values. So such type of schema, such type of arrangement, it is now based on the product key value pair. this key has different value, this key has a different value, this key has a different value. Such type of arrangement is possible in the case of the key value pair NoSQL database. So I'm hopeful that it is clear, like how we can use key value pair to store the inventory in the e-commerce website, any of the e-commerce website. Because I'm considering e-commerce example since the previous session, I'm continuing with the same approach. Because I'm not saying it is not practically possible to store this data in the SQL, but it will be more easy to store our inventory in the form of key value pair when we talk about the e-commerce website. So it is better suggestion to use some NoSQL data that stores key value pair. So one of the example of such a database is Amazon DynamoDB. Another example is RIAK. RIAK. So these are some of the example of key value pair NoSQL databases. So now we are moving to the next part of the database. Second is the document. Where is the mouse? Second is the document. Second is the document oriented databases. So it is the second type of NoSQL database. In document oriented database, we will maintain a collection of data. We will maintain a collection of data in the form of documents. Now, what it means document? So documents are generally, a simple example of document is JSON file. JSON file. So in the document database, data is stored in the form of a document. Data is stored in the form of document. And each document is typically a nested structure of key and value pairs. So simply what we are saying, we have data in the form of documents, and in the documents we have multiple key value pairs. So we can take an example of orders. In the e-commerce website, we can take the example of orders. So each of the order, like since why I am taking the document in a database for the order. See, let us say Kuldeep is placing one order. It has only one item. Then Mohit is placing the order. It may have the two item. Then let us say Rajiv is placing the order. It may have the, let us say, 3 items or more, maybe 4. So because each of the order, it is not fixed. It has one item, it has 2, it has 4, maybe some order has 1 item, some order has 6 item. Also, item may vary. First order has only book, second order has book, and let us say AC, third has book, AC, let us say refrigerator, accordingly all those things. So ultimately, to store the order, I will use the document, and to store those different items, I am using the key value pair. I cannot even fix the format of document because every document is now varying. First document has one order, one item. Second document has 2 item. Third has 4. Fourth has 1. Fifth has 6 items. So accordingly, because I can't fix such type of things. So that is why probably the document database, we will arrange our items in the our order in the form of document, and each document is characterized by one of the key. Each document has one key, or simply you can say ID. So we have document ID. We have document ID. Let us say in the case of e-commerce website, we have the order ID. So we have the order ID. This is my order ID. So order ID in the case of e-commerce. Now in this my order, what can be the situation? Like Kuldeep is placing the order. Kuldeep order has ID 1000, 10,001. So I can say in this case there is a this is my key. Okay, so I am keeping my order ID detail for my information purpose here. Then this has some item order. So I can case item orders are.
ਵੀ ਸਾਨੂੰ ਵੀ ਤਾਂ ਡੱਬਾ ਮਿਲਿਆ ਤੁਹਾਡਾ ਤਾਂ ਕੋਈ ਰਾਈਨ ਬੰਦਾ ਸੀ ਮੰਮੀ ਕਹਿੰਦੇ ਮੈਂ ਤੈਨੂੰ ਉਦੋਂ ਦੀ ਕਹੀ ਨਹੀਂ ਆਨੀ ਵੀ ਮੈਂ ਉਧਰ ਵੀ ਦਊਂਗੀ ਵੀ ਉਧਰ ਵੀ ਦੇਣੀ ਆ ਨਾ ਵੀ ਮਿਠਾਈ ਵੀ ਜਿਵੇਂ ਮਾਸੀ ਦੋ ਹਿਸਾਬ ਨਾਲ ਲੰਮਾ ਵੱਧ ਮੈਂ
So in my such type of document, I can say order ID in some orders, item order, like I can place book here, then book field is there. Accordingly, let us say I'm placing some other order with order ID 2, then that has some, so this is my key, and then that has some items like item 1, item 2 as the part of the order. So to store such type of documents, to store such type of information, we can use the document-oriented databases. So an example of document-oriented database is MongoDB, Apache, CouchDB. Such type of examples are document-oriented databases. Third type of database is columnar. So what is a columnar databases? So in this case, when we talk about the SQL database, generally we are storing our records in the raw form. We are storing our data records in the raw form. But in the columnar database, we are storing our records, our data in the columnar format. So that is organized in the columnar format, which are groups of column that share the same attributes. So we can take the simple example of e-commerce website again. We are considering like we can say we have row key, again we have the key, and then we can have the multiple columns for that. So let us say there is customer ID, whose customer ID is 101, let us say, then column 1 has its name, then column 2 has, let us say, contact info, then column 3 has, let us say, age. Now in the name, we can have only first name, surname, no last name. Contact info, we can have a single email ID, we can have single phone number. Age, of course, let us say we have single value. In the second row ID, we can have another person. It is not like fixed now. The second person can have name, and it can have the first name, surname, and the middle name as well. Okay, so it has only first name and surname, but it can be the first name, surname, and middle name. Column 2, instead of contact info, it can be something like that country. What is the country of the person? So such type of arrangement is possible with the help of the columnar databases. Now one of the popular example of columnar database is HBase. HBase is one of the very popular common example of columnar database. Another example is Cassandra. Cassandra by Facebook. It is one of the another example of columnar databases. Similarly, we can have the graph-based databases. So 4 type of databases is graph-based databases, NoSQL databases. So generally, sometime we want to store our data in the form of graph to do the graph-based analysis. Like in the case of e-commerce website again, because we are considering that again example, there is, let us say, Kuldeep is here. This is Kuldeep. Now they are making now e-commerce website. They have the knowledge, like they have like hired some data, let's say from the Facebook or some other website. Let's say they come to know Kuldeep and Mohit are related to each other. Kuldeep is friend of Mohit. Or based on association rule mining, based on different way, based on collaborative filtering, they come to know Kuldeep and Mohit. They have the same purchasing behavior. So what type of graph they will make? Kuldeep, Rajiv, Mohit, Vijay, then let us say Susil. So such type of graph they are making. So based on the same purchasing history, they come to know Kuldeep and Mohit have the same behavior. Kuldeep and Vijay has the same behavior. Kuldeep and Rajiv has the same behavior. So accordingly, if let us say Kuldeep is purchasing some item, they will recommend to Vishal. They recommend to Vijay. Accordingly, Vijay is buying, so they can also recommend to Sushil to ensure that there should be some connection in the future between the Kuldeep and Sushil. So such type of relationship is possible with the help of the graph-based databases. So in the graph-based databases, we will make the social network. We will make the social network. In this case, nodes are the actual data and edges are relationship between those data. And we use the static social network analysis to know the relationship between the databases. Such type of information become difficult to mention in the case of relational databases, like who is the friend of who have the likely purchasing behavior. Such type of relation, it is sometimes become difficult to store in the key value pair, in the document, in the column, and it is better that we will use some graph to denote such type of data. And alternate to that is now graph-based databases. Like for example, if we want to denote this relationship with the help of the key value pair, so we have to make multiple key, K2M, K2V, K2R. So it becomes difficult. Like some of you know in the graph adjacency matrices, they become difficult to manage. But when we have the graph in simple form, probably we can easily understand how to do all those analysis with the help of the social network analysis. So depending on the requirement, we have data. We have large variety of data depending on what type of operation we have to do, depending on what type of query we have to perform on the data. So we can set up our data to be use any form of the NoSQL database. We can use key value pair, we can use document oriented, we can use column oriented, and we can use the graph oriented databases. A very popular example of graph data store is Neo4j. So what is the common example? Neo4j. It is very popular example of the graph based data storages. So if I will summarize, one of the popular key value data store is by Riak. It is Riak and Apache and Amazon Dynamo. One of the popular example of columnar data storage is Cassandra HBase. One of the common example of documents data storage is MongoDB. And some of you surely used the MongoDB in the past. Many students are using MongoDB, like MongoDB for documents data storage. And as a teacher, we know like what they are using. So we should also know what is MongoDB as per our requirement. And Neo4j is one of the example of the graph data storage. So now we know how to query the data. So, but next part is like how we can store our data in the native format, in the file system, and how we can process over that part on that data. To support storage of data in the native format without processing, and to ensure processing of the data, we have the Hadoop framework. So Hadoop is by the Apache. It is a open source software framework. It has two main components. One is the HDFS part and one is the MapReduce part. So what is the purpose of HDFS part? Hadoop Distributed File System. The full form of Hadoop is Hadoop Distributed File System. It is the storage component. It distributes data across the several nodes, and the positive point is native. It is stores the data in the native format, and that is redundant. I will go to each part why it is redundant, why it is distributed. But let firstly understand basic part. HDFS stands for the Hadoop Distributed File System, and is the storage part of the Hadoop. It is inspired from the Google file system. Second part of the Hadoop is processing part. So it is the storage part. It is the processing part. What is the purpose of the processing part? It is the computational framework. It will process the data. Now we have data stored into HDFS, but data is of no use until we are not able to process it. So ultimately we have to process that data. So that is possible with the help of the MapReduce. And MapReduce has some feature. Firstly, it will split the task across multiple nodes. Second, it will do parallel processing. So ultimately, what we simply can say, it is based on the parallel and distributed processing environment. MapReduce use parallel and distributed environment. It also divide the processing, like it will also process the data in parallel, and it will split the processing across the multiple node. So let us cover each of these HDFS and MapReduce briefly to understand how HDFS work and how MapReduce work. So when we talk about the Hadoop high-level architecture, in the Hadoop, it is a client-server architecture. Hadoop is a client-server architecture. Okay, so based on past knowledge, so far we come to know that part कि we have large volume of data. We already know we have a large volume of data. Second part, we have the variety of the data. So to handle the variety, we already know one solution, like what we can do. Now to handle the large volume, first thing we have to focus on how to store it, because it is not practically possible to store all the data into one node, into one process, like PC or one particular device. So that is why we have to store our data into multiple devices. Okay, first part is because we have a large volume of data, so we have to store our data into multiple devices. Second, because we have a large volume of data, we cannot use some quality hardware to store the data. Let us say I have terabytes of data, and my maximum disk capacity is, let us say, in GB. So I have to use multiple disks. Second, because I have a large volume of data, that may be useful, that may not be useful, that we don't know. Data, we have abundance of data. Some of data may be useful to us, some of data may not be useful to us. So that is why we have to use some commodity hardware. What we will use? We will use some cheaper hardware to store our data. So when we are storing our data, we will store our data into multiple storage. First part is clear. Second, we will use cheaper hardware to store our data. So we have multiple disk, simple part, and we will use the cheaper disk, cheaper one, because we want to optimize the cost. Industries want to optimize the cost of storage as well. RAM is costly, like as compared to hard disk, or even in the disk, some like SATA, like SSD is cheaper than the costlier than the HDD. So tapes are even more cheaper. So accordingly, we will store our data into cheaper hardware. But when we are storing our data into cheaper hardware, the chances of failures are more. Chances of failures are more. So that is why, because chances of failures are more, we are using the cheaper hardware. What if some disk get crashed because it is of cheaper quality? And that is why we have to replicate our data into multiple cluster. And that is what part here, natively redundant. So we are distributing the data across several nodes, and we are doing the redundancy to ensure that, let us say by chance some hard disk get crashed, some device will get crashed, then ultimately we are able to recover our data from some other node in that case. So that is about the storage part. So based on that, now because we are storing our data into multiple different storage, we need some meta information. I need some device, I need some node that will store the meta information of all those clusters where I am storing my data. So that is why I need some like some master who will keep the record of all those locations where data is stored. So that is why, based on that, I come to know to manage the data, to store the data. So I have some nodes which will act as a storage part, and there should be some node that will act as a master that will keep the meta information of where I am storing my data file where I'm storing my data. So based on that, we have this master slave architecture, in which case we have a master node and we have the slave node. In the master node, we have HDFS. In the slave node also, we have the storage unit as well. मास्टर के अंदर भी हमारी स्टोरेज यूनिट है, स्लेव के अंदर भी हमारी स्टोरेज यूनिट है. सो व्हाट इज द पर्पज ऑफ slave storage unit? It is used to storage our data. Let us say I have some 1 GB data file, 1 GB data file, or let us say large data file. Let us say I'm making it, instead of 1 GB, let us say I'm making it more, let us say 256 GB data file. And I can store only, let us say 64 GB of data into one disk, into one node. So I have to distribute, I have to divide that my 256 GB data file into 4 files. Am I right? Because I can store only file of 64 GB and my file is 256 GB, or maybe let us say 246 GB. So I have to divide that into 4 chunks. So I will store that into 4 different nodes. Further, I want to replicate those. Maybe I am storing that single file into multiple location. So those will be stored into these areas. इनको हम where will store? We will store these data files. 256 GB data file into different chunk. हमारे पास एक फाइल है. Let us say we are making 4 chunk A1, A2, A3, A4. We are storing that into different slave nodes here, A1, A2, A3 here, A4 here. Let us say replicating again A1 here. And so this storage information, we are keeping that into this particular meta information key, in which slave node we are storing the file. That information is in this particular meta information. One part is clear. Now what will happen? It may be the case that because this is also one of the node, it may also get crashed. If it is crashing, we handle it accordingly. If it is crashing, we will handle it accordingly. Let us say master node will also crash. So to handle the crashing of the master node, we'll make one secondary master node as well. That will also, it is secondary master node. So what we will do, we will periodically update our secondary master node. If by chance main master node will crash, then secondary master node will get the update from the this information where the data is stored in the slave node. That information is received from the secondary master node to the master node. So when the master node will crash, secondary master node will become the main master node, and we will make some another node into the whole architecture as the secondary master node in that case. Okay, so that is the HDFS part somewhat. How HDFS is like how we are managing the storage part. Beside that, we have the computation as well. We are storing the data. One part is done. We are storing our data into the different node. Now, because we have a large volume of data, we have to process that also. So a simple case, if I take a very simple example to understand, if I have, let us say I have to find the largest of 1000 number, one approach is like that. I will take 1000 number and find the largest value from that. I am storing all the 1000 number into one storage and finding the largest from that. Another approach, what I can do, I do parallel processing. I will find the largest out of 100. I will find largest out of 100. I will find largest out of 100. I will find largest of 100 up to 10 times. So I process this into different machine. I process this into different machine. And out of those, I get the 10 value and I will find the largest among those. So if I will process this value, like let's say I'm using ultra-O(n)-square algorithm, the complexity will be large. But in this case, when I'm doing O(n)-square with the 100 value, and I'm doing this in parallel, then my complexity will be decreased. And that is the idea about the MapReduce part. So what I'm doing, when I have the large data, 256 GB here. I divided that into smaller chunk. I am putting my smaller chunk into HDFS storage. So instead of combining all those chunk, 64 into 64 4 times, what I'm doing, I'm passing my processing part to this chunk. So there is now one difference as compared to data analytics now. When we move to the big data analytics, in the traditional data analytics, we are actually moving data to the code. Data to the code. In the traditional approach, in the traditional data analytics, we are moving data to the code, and you will actually do like you have some code, you are running the code, and you are passing the data to work on this. But in the case of big data analytics, what actually you are doing, you are passing your data, you are passing your code to the data. So in the case of big data analytics, we are moving code to the data. हमने क्या किया, we are moving code to the data. This is my code, computation part. So we moved our code near the data. So this part, this computation part will work on this data, this computation part will work on this data, and this computation part will work on this particular data. And hopefully in the real time, these will be similar. These computation will be same. This code will be same, this code will be same, this code will be same. So such type of architecture is called our Hadoop high-level architecture. So in the high-level architecture, we have the one master node that has the computation part, that has the storage part. In the slave node, we have multiple slave node. Each slave node has some computation part. Each slave node has some storage part. So when some large file we have to store into the Hadoop architecture, we will divide that file into subpart depending on the default size, and we will store that into different slave nodes, assuming the replication factor, because we are replicating. Why? It may be possible that some slave may get crashed over the time because we are using the cheaper hardware. And let us say some slave will crash. Then because our storage has the information, what actually that particular slave node will have, so it will replicate the same slave node into a new node by using the meta information available into the storage. So similarly, our master node has the MapReduce part, our slave has the MapReduce part. These MapReduce part which are in the slave, they will work over those data. And the master node has the MapReduce part, it will control over all those MapReduce. So we have some job, let us say finding the largest of 1000 number. So that job is divided into subpart by this MapReduce. And those subjobs, now we are seeing the technically task, these will be performed by each of the slave node in parallel. So such type of architecture is possible with the help of the MapReduce part. Okay, so if we talk about the HDFS daemon, as I suggested, we have the name node, we have the data node, and we have the secondary name node. So what is the name node? So name node is single name node per cluster. This is our name node. This is our name node in this case. So we have single name node plus cluster. It will keeps the metadata detail, and it is within the kahan par hota hai? In the master node. It is the part of the master node. Similarly, we have multiple data nodes which are part of the slave nodes. So we have multiple data nodes per cluster, and we are doing actually read-write operation over that. And similarly, we have the secondary name node for housekeeping the purpose. Let us say by chance name node will crash, so secondary name node will take over the name node. So this is the HDFS daemon. Okay, and we will do the replication. By default, replication factor in the case of HDFS is 3. Like each particular data is now replicated into three nodes. So we are replicating the data into 3 locations, 3 physical or logical locations as per our architectural design. Okay, so second part of our this discussion is after the HDFS, we have the  So what is the MapReduce framework? So in the MapReduce, we have two things to under. It is the processing part. First thing, it is the processing part. It will process our data. So from the data, it will gather the relevant information. How can I take the example? We will take one example. Let us say we have a large file. We have a large file which is not practically possible to store into one node. So we have to divide that into multiple files. We already covered. So we will store this into some node, this into some other node, this into some other node, this into some other node. Okay, so that is like maybe in one slave node, this file is there, another slave node, this file is there, another slave node, this file is there, another slave node, this file is there. Okay, so now one approach is that when we have to process this data, one approach is like that we will combine all these data units into the single large unit and process it, but that will be time consuming. Also, we don't have enough storage to store all this unit at one place. So what we have to now do, we have to move our code. We have to move our code. This is our processing code to this unit, to this unit, to this unit, and to this unit. We have to individually process this unit. We have to 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 get the results from that. 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 And then we have to aggregate the result to make the final output. And that we will do with the help of the MapReduce. What the MapReduce will do, it will divide. It will now, what it will do, MapReduce, it will it will work on the part of the data. It will process the part of the data, then aggregate the results. That part, splitting the data, working on that, and aggregating the results, that will be done with the help of the MapReduce part. So it has two parts, phases and the daemon. So it works with the help of the MapReduce concept that we will cover after a few minutes. Second, it has the two daemons. Like we have the daemon here, name node, data node, secondary name node. MapReduce has the two daemon. One is the job tracker, second one is the task tracker. So job tracker is part of the master node. Task trackers are the part of the slave node. So the purpose of job tracker is to schedule the task, and the purpose of task tracker is to execute the task on the slave node. So how simply we can say, let us say I have the large file and I have to find the largest number. So I have to find the largest number out of those files. So actually what is happening, I have this architecture. Let us say my file is at the 4 different nodes. This is my large file A, that is split into 4 chunks, A1, A2, A3 and A4. So A1 is at this slave node, A2 is at this slave node, A3 is at this slave node, A4 is at this slave node. So these are my slave node, and ultimately I can say these are my data node. Okay, so in my master node, I have the name node part. It will contain the meta information. What is the meta information? Like I have the file A that has the 4 chunks, A1, A2, A3, A4. A1 is stored at, let us say this is the data node. This is the name node, slave node 1, slave node 2, slave node 3, slave node 4. So this chunk this has the information ki A1 is in the slave node 1, A2 is in the slave node 2, A3 is in the slave node 4, A3, A4 is in the slave node 4. Of course, these are replicated, so A1 will be also part of some other slave node as well. So now this information, now what is the role of, so we have the job tracker here and we have the task tracker here. So we have the job tracker above and task tracker here. So what is the job tracker will do? So job tracker will take some operation as input that we want to do over the A. Let us say I want to now find the largest value among the A. My file is now distributed at the 4 slave node. So this job tracker, it has the meta information. It will schedule my task into 4 nodes, here, 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 and here. It will do the task of scheduling. So this task tracker, this job tracker, sorry, it will pass the code. So what is the big data analytics? Moving code to the data. So now code come to this task tracker part, task tracker part, task tracker part, and task tracker part. So each has sub file out of the large file. So largest among A1 is found by this task tracker. Largest among A2 is found by this task tracker. Largest among A3 is found by this task tracker. Largest among A4 is found by this task tracker. So ultimately then it assigns some other node, some dummy node, some other slave node, that is SN5, to process the output of those largest of this, largest of this, largest of this, largest of this, to find the largest among the A1 plus A2 plus A3 plus A4. So that is the part of the job tracker. Scheduling all the job, scheduling all the coding operation on the task trackers. That will be done by the job tracker. So this part, mapping data into different tasks, that is done by the mapper, and this reducing the result is done by the reducer part. So now we are covering that part, what is the mapping part and what is the reducing part in detail. Any doubts so far? This time I'm slow for this part. If you are still, if you are able to understand, yeah, any question? I think no. So now we are moving to the next part. In this case, give me 1 minute break. So to understand the concept of map reduce, let us take a very simple example. I'm taking from one of the book by Anil Maheshwari. So what is the example? Okay, so as the discussion so far, we have in the map reduce, we have one job tracker, we have multiple task trackers. Job trackers schedule the job, task trackers execute the task. But how it actually works? So we have the concept of map and reduce here. So what is the map and reduce here that we want to cover now? So we have the concept of map, sorry, we have the concept of map and reduce. So what is the idea about the map and reduce? Out of when we have to process the data, we have data over the different data nodes. We have our data over the different nodes. Now the master node, or you can simply say name node. So this is my slave node. This is my slave node. So master node, what it will do, yeah, name node, what it will do, it will map the data. It will map the data into different slave node. So we can consider the same example, a simple example. Let us say we have a file that consists of the following information. So there is a large file. The file has information like we are going to a picnic near our house. Okay, many of our friends are coming. You are welcome to join us. We will have fun. So this is simple text which I am considering. It is small enough to understand the concept, but assume that this text is very large, and it is not practically possible to store this large volume of data into one of the node. So ultimately what we are doing, we are splitting this data into different part. So this is one part, then second split will be from here to up to coming, then third split will be here, then fourth split will be there. So what we are doing by this example, we have the problem of word count. I will take two example. One I am taking the word count, second I will take the different example. So ultimately one approach, we want to count the occurrence of each word into the file. Occurrence of each word into the file. One approach is like that. When our memory is enough to hold the whole data, we can use any recursive approach. Firstly, count all the V, then count all R, then count all going in that way from the whole file. That is one approach. But since the file is very large, we cannot store all the file in one node. So that is why we are storing this part of the file into one node, this part of the file into second node, this part of the file maybe let us say third node, and this part of the file may be at the fourth node. You can assume this is the 1000 GB file, and we can store only 256 GB at one memory location. So we are storing 256 GB in one node, 256 GB into another node, 256 GB into some other node, and the remaining into some another node into the memory. Now, if I have to find the word count, so my job tracker responsibility is to find the word count from the whole file. But my file is not, this file is at this node, this file is at this data node, this file is at this data node, this file will be at some other data node, slave node storage. So what we are simply doing, what the job tracker will do, it will move the code to find the word count to each of the task tracker, to each of the computation MapReduce part. So code will come to this part. So it will work on this part. It will apply word count on this file. Another will another slave node work on this file. Other slave node will work on this sub file. Another slave node will work on this sub file to identify the word count. And how it will be done? It will be done with the help of the MapReduce. So what we will simply do, we will map this as the key and the value. How many times this word is coming? So we are going to a picnic near house. It is coming one time. So our key becomes this one, value becomes 1. Our key becomes many of our friends are coming, value becomes 1. You are welcome to join us becomes key, value becomes 1. We are having fun, it becomes the value, it becomes the key, and value becomes 1. So we have the fork in the corresponding value. Now what the mapper will do, mapper is one of the slave node, we have to find the word count. So we will now split our key value, we will convert our key value pair into K1 in V1 pair. So initially our key is whole sentence and value is the occurrence of that sentence. Now our key is word, unique word, and V1 is the how many times that word is coming. So key value pair. So we can simply say like V is coming one time, R is coming one time, going is coming one time. So such type of key value pairs we are generating with the help of the mapper part. So the reducer part, what it will do, it will now aggregate all the files and it will now combine those K1 V2 values, sum of multiple V1s to get the final result. So I am considering this example from this way side to understand this part. Let us say this is the input file, this is another input file. So one of the data node. So we are splitting we are passing this file to individual mapper. This is one to one mapper, this is another mapper, this is another mapper, this is another mapper. Now we have key value pair, apple 1, orange one time, mango 1 time, orange 1 time, grape 1 time, plum 1 time, apple 1 time, plum 1 time, mango 1 time, apple 1 time, apple 1 time, plum 1 time. So this is our initially KV, it is now K1 V1. So now what we are doing? We are aggregating. Again, it is K1 V1. Sorting and shuffle does not change the key value. It is K1 V1. It is also again K1 V1. K1 are apple, grapes. V1 value are their frequencies. Then we have the reducing part. In the reduced part, we have the K1 as the key, and what is the value? Value is the V2. V2 is the sum of this value, and this is our final outcome. So in that way, we are applying the key value pair to, we are doing the mapping part and the reducing part to count the occurrence of the word. So one question that comes from this discussion is like that, we can only split our problem into sub-problem, or we can simply say, we can split our job into task only when we can do the parallel processing. So MapReduce is good when we can do task in parallel. When the output of one task depends on the other task, or input of one task serve as the input to other task, then we can't go with the parallel processing. So MapReduce is good when we can divide the task into parallel task. Only then, when we can divide the job into multiple parallel tasks, then only MapReduce is fine. Second, MapReduce is only useful when we have the large file. When we have the small file, see, we can simply process a small file with the traditional approach, traditional calculation. We don't need to go with the MapReduce framework. We don't need to use mapper, like move code to the data when we have the small file. We can easily even move data to the code when we have the small file. So that is why MapReduce is only good when we have the large file. When we have the small file, then better move data to the code. Like simply do the traditional data analytics part, do the traditional like processing part. Don't move your code to the data in the case of the small file. It will be not a cost-effective solution in that case. Now we are taking some other example to understand whether we can apply MapReduce here or not. This example is taken from the internet. Let us say, assume that we have five files. Each file contains 2 columns. So we have five files. हमारे पास 5 files हैं. Each file contain 2 columns. First column is the key. Second value is, you can say, assume the value. So in the Hadoop term, and we can say each file has 2 fields. First field is the city, and second is the temperature. Second is the temperature. So I have 5 files similar. File 1 that has the city temperature, file 2 that has the city temperature, similarly another file, similarly file. So city is the key, temperature is the value. So for example, one of the file has Toronto and 20 as one of the data. So out of all the data, all the file, we want to find the maximum temperature for each city across the all data files. So we have the 5 file, and it may be possible that some same city is repeating in multiple files, and we want to find the maximum temperature for each city. So one approach is like that. I will take the file 1. I will find the unique city from that, correspondingly find the unique temperature, highest temperature for that. Then I will work on the second file, found the same city which are repeated in the file 1, or found some new city from the file 2, then found the maximum for that repeatedly until the file 5. What can be the other option I can do? I can use MapReduce to break down my task. So what I will do with because I have the 5 file, we can have the 5 mapper. Each mapper will work on each file. Each mapper will work on each file. So what the mapper will do? So from each file, we are extracting the information. We are extracting the city name, key, and the corresponding value. We are extracting the city name and the value, key and value. So this is the key. This is the maximum temperature from each file. So in the first file, there are 4 unique cities. Let us say Toronto, Whiteby, New York, and Rome. And their maximum temperature is 20, 25, 22, and 33. Similarly, my second mapper will found temperature from the second file, maximum temperature for each city from the second file. Third mapper will found the maximum temperature for each city from the third file. Fourth mapper will find the maximum temperature of each city from the fourth file. Fifth mapper will find the maximum temperature for each city from the fifth file. Since the finding the maximum temperature for each city from each file is independent of the other, I can run these my 5 mapper in parallel. And that is the beauty of the mapper part. That is the beauty of the MapReduce. I can divide my job into subtask. I can divide my job into sub-job or simply task. And each task will work on one part of the data. Like each task is now working on one of the file out of the file. In the reduce part, what we will do, one of the data node will take this as the input, this key value pair. It will find the maximum for Toronto city. It will find maximum for this. It will find maximum for this. It will find maximum for this as the final result. So that is some way by which I can use MapReduce to find the to process my data. So simply what the MapReduce is doing, in the MapReduce, there is a few critical points in the MapReduce. What are the critical points? In the MapReduce framework, our data is now distributed across the multiple file. So since our data is distributed, and I can divide my job into multiple tasks, and each task I can do on the distributed part of the file, and later I can combine those as results to make the final decision. So that is the idea about the MapReduce. Divide your job into multiple tasks, work on those tasks, and then combine the result to generate the final output. So in that way, we can do the MapReduce part. Okay, so hopefully you are able to understand MapReduce part based on this understanding. Now we are moving to the next part of the part, like when we have, so this is, if we go to our initial slide here, volume we are able to handle, variety we are able to handle. Now we have the velocity. We have a large volume of data coming from the different sources. How to handle that part? How to handle the velocity part? So to handle the velocity part, we have 2 technologies which we can use. First one is the data stream models. Second one is the Spark. Spark is part, like we can use Spark with the Hadoop framework in replacement to MapReduce to have the real-time processing. So that will be difficult to ingest within 20 or time in discussion. So I am keeping Spark as a future exercise for you. 1 minute, give me. Second part is that we will focus on is the data stream mining. So what is the first question arising in our mind is what is data stream? So in the real world scenario, if we will take the real world example, we want to do some real time analytics, like on the Google, when we are searching something. Ultimately, it is not in the control of the Google how many people will search. It may be possible like that many people are searching at 6:12, but only a few people are searching at 6:13, or maybe more people are searching at the 7 p.m. So the generation of queries is irregular. It is not in the control of the Google ki how many queries are generated over the time. It is something irregular. Similarly, when we take about the Amazon example, of course, Amazon want to take the order. It is the e-commerce website. They want to take as much as order they can take. But it is not in their control when the order will come. It may be possible that in the 1 unit of time they received 1,000 order. In the next unit of time they received 2,000 order. In the next unit of time they are receiving only just 500 order. And even we have some another example like that where such type of situation may happen. So this stream of data that is generated over the time in the irregular way. So how I can ingest this stream? We cannot go with the traditional databases. In the traditional databases, we are working in the offline way. In the even in the when I downloaded all the video from the, let us say, from some sentiments tweets I have downloaded, I am working in the offline way. But sometime I have to process my data in the real time. I have to actually store my stream as well. If I am not able to store my stream, if I am not able to store my data in some storage location, it will lost out. Like in the Google, whenever we are searching, Google is storing all those queries done by Kuldeep, done by Mohit, done by Vijay at some location in their whole record. If they are not able to store those queries in the real time, probably they will they will not able to predict the human behavior. They will lose some relevant information that may help in the future to enhance the business. So as a company owner, as a in the real world scenario, what we want to do, every company want to ingest means hold on to store all the data, and that can be possible with the help of the data stream processing. So in many data mining situation, we don't know the entire data set in advance. Like in the e-commerce website, we don't know how many orders will be placed now, in the next 1 day, or in the next 2 days, or in the last 1 day, how many orders are actually placed. So when data is not in the control of the user, when the data is not in the control of the person who want to analyze the data, then we have to rely on the data stream processing model to store the data, to process the data, to analyze the data. And so this is a simple example of the stream processing model. In the stream processing model, all this some of this data is motivated from the textbook by Raja Raman. He's professor in I think CMU. I'm not sure exactly. Wolf Allman and all those faculty. So this is the how we can assume a journal stream processing model. We have one processor. Since we have the limited working storage, so the stream of data is generating over the time. So each stream composed of multiple elements and tuple, but we can assume this as the stream of items. Like in the case of e-commerce website, because we are considering the e-commerce again, so we can assume we have some stream, like over the time we have one stream for one book. Let's say for book. So this is the order in order one. So this is the time over the time. So first order has book note. If the book is in the order 0, if the book is not in the order 1, accordingly. So that we can have the some streams over the time. So this is the stream of data. These are called tuples of the stream. So we have to now process. We have to make some decision over the stream. So what we can do, we can use some limited working storage to store the stream. That is practically possible if the stream is coming with some small pace. But sometimes the stream comes with the faster pace. and it is not practically possible to store all the data into the working storage. So what we can do, we can archive our storage. We can archive our data from limited working storage to the archival storage. Now we have two ways to archive. We have two ways to archive. First way is that we are archiving all the data. In the archival, we are storing the all data. Like from this storage, we are storing all the data. Maybe 10 years old, 20 years old, all the data we are storing. But that is not practically possible. We can't archive all the data. So what is the second approach? We make a sliding window. We make a sliding window. Sliding window means, let us say we are storing the data of last 10 days, last 10 unit of time. So that is the second way of archival. We are ignoring the old data and storing the latest data into the archival storage. What is the another way? What is the third way? How we can archive the data? See, from the data which is in the limited working storage, we are extracting the relevant patterns. We are extracting the relevant patterns with the help of the processor, and extracting that information we are storing into the archival. So we are ignoring the whole stream which is in the limited working storage, and from that stream we are extracting relevant pattern and only storing that into the archival storage. So all those things are possible when we are handling the, just 1 minute, when we are handling the stream processing model. Okay, so now a question may arise in our mind. See, when we are working the data stream processing, since it is not possible to store the whole storage, like if we will do that part, so how we can do, how we can work on the streams in that way. So first of the approach that comes under this category is sampling data in a stream. So first approach is sampling data in a stream. So what is the stream? Stream is the data that we are generating over the time. So this is our stream which we are generating over the time. Let us say this is the time, this is the latest element, this is the old element. So one approach is like that, we are sampling a fixed proportion of the element in the stream. And second approach is like we are maintaining a random sample of fixed size. What it means? Let me explain one by one. So when we are generating data over the stream, it is not practically possible to store all the data. It is not practically possible to store all the data, all the stream, because we have a limited storage. So we will use the concept of sampling. What is the sampling idea? We can assume this is our whole population. That is, we are getting new element over the time, new tuple element over the time. And because we cannot store whole stream, we cannot keep the record of the all data. So what we are doing, we are making some assumption. We are sampling a fixed proportion of element from the stream. What it means? Let us say 1 in 10. So what we are doing, out of the 10 element which we have seen so far, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we are sampling one element into our storage. So we are storing only one element, let us say randomly out of those, into our storage. So if we have seen 100 elements from the stream, we have in our storage, in our archival storage, we have the 10 element. If let us say we have seen the 1000 element, then we are archiving the 100 element. So such type of approach, that is called, we are sampling a fixed proportion of element into the stream. But that also has the limitation. Like let us say we have 1 million of elements observed so far over the time. And out of 1 million, or let us say 10 million, we have to store 1 million element. Out of 10 million, we have to store 1 million element, because we are sampling a fixed proportion, 1 out of 10. Even we don't have space to store 1 million element. We don't have even space to store 1 million element. What we will do? Also the reverse case, we have seen only 100 element, and we are using the sampling. In the first case, 1 out of 10, we have only 10 sample. So 10 samples are not sufficient to make the decision. 10 samples are not sufficient to make the decision. 1 million samples we cannot store if we have the more sample. So to handle that situation, we have the case we are maintaining a random sample of fixed size. What it means? We are maintaining a random sample of fixed size. Let us say our sample will be always 1000 samples. So as soon as stream is generating the data up to 1000, we will directly store those tuples into the sample. And if a new instance come, if the 1001th instance will come, then we will replace one of the sample from the data set with the 1001th sample. So that is, we are maintaining a random sample of fixed size when we are doing sampling over the data stream. So in this approach, what we are simply doing, if I were to say in a simple form, we have stream of data over the time. It is not practically possible to store the all data. So we are using the simple concept of sampling. We are doing the simple concept of sampling. One approach is like that. Our sample size is proportion to the stream size. Second approach is we are keeping a sample of fixed size. And depending on the requirement, we can use any of the sampling approach. Our next part is filtering the stream. What it means by filtering the stream? Since in the distributed environment, our environment is now distributed, it may be possible that a particular data set, it is distributed across multiple node, across multiple storage units, because our data is very large. It is not practically to store at the one location, and that is why we are storing our data into multiple locations. Now, if I have to search over the data, if we want to find whether a particular value, so what I'm considering the situation, let us say I have a data file, I have a data set, because it is very, very large, and I splitted that into multiple storage units. So it may be here, it may be here, it may be here, it may be here. So it will be on the 4 storage unit. Let us say I want to search a particular value V into this data set. So one approach is like that. I will search over here. If I found V in this data storage unit, I say that data is found. If data is not found into this particular storage, I will check the next data storage. If not found, I will check the next. If not found, I will check the next. So I am searching in a linear way. This is not time efficient because I have the million of data. I have the billion of data. Searching a particular value into billion of data is not time efficient. So in that case, can I think about some way by which I will filter out? I will filter out key based on the value V. I can make some prediction based on the value, based on the V. It can be only in this particular data storage. It can be in this particular storage only. It can't be here. It cannot be here. So I'm filtering my storage. I'm filtering my stream. When I have to search a particular value, I am not looking on the all storage unit. I'm looking only a few of the storage unit. So such type of idea is called filtering data stream. And so what we can use? So we want to find a particular value looking as much as less chunk we can do. So we want to look a few chunk as possible. So we want to look a few chunks as possible. So what we can do to do that part, we will use the concept of Bloom filter. So we'll use the concept of Bloom filter to do that part. So Bloom filter is very important data structure. And what is a Bloom filter? Bloom filter is actually a sequence of bits. It is simply an array of bits. if I will say what is the Bloom filter? Bloom filter is an array of bits. Array of bits. When I'm saying bits, it means it is simply 0 or 1. It has the possible two value. So what simply we are doing, we will apply for each dot chunk, for each storage unit, we will create a Bloom filter. We will create a Bloom filter for this chunk, indexing, simply indexing. We will create a Bloom filter for this chunk. We will create a Bloom filter for this chunk. We will create a Bloom filter for this chunk. Okay. So now each Bloom filter is characterized by some hash functions. It is characterized by some hash functions. Now, if the Bloom filter will say, no, what it means, if Bloom filter will say that a particular value is not into the chunk, it simply means that the value is not into that particular chunk. Let me cover one example, then you will be able to understand this part. So what is the Bloom filter? Let me first explain that part. So a Bloom filter is simply an array of bits. It is an array of bits, with a number of hash functions. So each Bloom filter characterized by two things. One is the hash function. Second one is the size. So initially, all the elements of the Bloom filters are 0. Initially, जितने भी element है Bloom filters के, they are 0. So let us say we are making a Bloom filter which has two hash function, h1x and h2x. What is the h1x? It will take odd numbered bit from the right of binary form of x. Okay, and then result is I mod 11. So let us say I have one, this is my storage here. Let us say 25 comes into the stream, and I want to store that into, I have 4 chunk here, chunk 1, chunk 2, chunk 3, chunk 4. So I have the option, I can store 25 into one of the chunk. So let us say I am storing my 25 into this particular chunk. I am storing 25 into this particular chunk. So 25 is represented in binary. How? 1 0 1 1 0 0 1. This is my binary representation of 25. So corresponding to this chunk, there is a Bloom filter. Let us say size of the Bloom filter is 11. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 10, 11. So this is Bloom filter. Initially, all the values are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So as soon as we are storing one into the chunk, 25, when we are storing 25 into the chunk, we will calculate the hash value corresponding to this. So what is the odd numbered value in this case? Odd number is 1. This is the odd. This is the odd. This is odd. So 1 0 1. This is the odd value. Mod 11. So we are getting it to be 5. So we are setting the fifth bit. Fifth bit is 1, 2, 3, 4, 5th. So we are set 0, 1, 2, 3, 4, 5th. So we are setting to the fifth bit to be 1. Similarly, what is the even value for what is the h2x? We are taking even numbered position and we are setting I mod 11. We are setting I mod 11. So even values are 1 0, 1 0 mod 11, so 2. So we are setting the second bit to be 1 in that case. So in that way, we are setting the bits. As soon as some values entered into the chunk, we are setting the corresponding bit into the Bloom filter to be 1. So let us say if some values are 1, some bits of the buffer are now Bloom filter are 1. Similarly, let us say there is some other value which will set this value to be 1. There is some other value which will set this value to be 1. Similarly, for another Bloom filter, we have some value set to be 1, some value to be set to be 0. Similarly, for another chunk, we have some value to be set to be 1, some value to be 0. Similarly, for other chunk, some values are set to be 0, some value are set to be 1. Now, if we have to find whether a particular value v is in any of the chunk or not, so simply we will find the h1 of x, h1 of v, h2 of v. If h1 and h2 value are correspondingly set to 1, then we will say there are chances that that particular value v would be in the chunk. If any of these value will be 0, the corresponding bit will be 0, then we will say that that particular value will be not be into the chunk. So of course that has the false positive. So that is the idea about the filtering the stream by which we can filter the data stream. Even over the time, when it comes to the big data analytics, like when we have the traditional data analytics, we have all the data in the main memory. If we have to apply clustering algorithm, we can go with the k-mean clustering, we can go with the hierarchical clustering. But when we have all the data not in the main memory, our data is scattered, or we cannot process all data in one go, then probably we have to rely on to different types of algorithm like BFR algorithm, CURE algorithm to process the large volume of data for clustering purpose. So big data analytics has different methods for handling large volume of data, all those things to process the large volume of data as per our requirement. So that is not practically possible to cover all those things in this lecture. I have already too fast to cover the topics so that I am able to complete on time. So this is all idea about brief idea about what is data analytics, what is big data analytics, what are the different technologies that we can use for big data analytics purpose. So if you have any doubt, you can ask. If you have any concern, you can ask. Otherwise, I am going with the quiz part. So I'm sharing the email by which you have to give the quiz. So I'm stop. So I'm sending the email for the quiz. Quiz has quiz has 20 questions in the 30 minutes. So there is 30 minutes for the quiz. Ma'am, it is via email. It is sent via the email. Link is sent via the email. So please complete the quiz. It is of 30-minute duration. Quiz is compulsory for the certificate.